All right, so we're going to determine this rate law. Okay, we're going to determine this rate law. Now, what is the generic rate equation?
Rate equals A bracket A close bracket B.
Well, A to some power. We're going to call that X. Okay, and B, and you could have used M and N. It doesn't really matter. B to some power. We're going to call that Y. Okay. So that's our first step we need to do. We need to write our generic equation. Okay. We need to write our generic equation. And now our next step is to do what? Lamaya, we would divide, we're going to divide, we want to determine X and Y, so we're going to divide two rate laws, okay? We're going to divide two rate laws. So what two rate laws would you start? Well, what two experiments would you start with? I didn't like your homework in some ways, and I apologize. Is this part was missing, okay? This part was missing, and when I was trying to explain, I was trying to say 1, 2, and 3. I like this part of it right there. That way it kind of shows a little bit better. I can't erase it now. So what experiments would you choose? Remember, you always want to divide the biggest rate needs to be on the top of the one you choose.
2 divided by 1.
What?
2 divided by 1.
2 divided by 1. Do we think that would work? No.
Wait, 2 and 1 is not an option, is it?
Yeah, you can divide in.
Oh, the numbers. I thought you were saying. You shouldn't do 3 divided by 1 because it would just be 1.
Well, you need something to cancel on the first one, don't you?
Oh, yeah.
So you don't want to use 1 and 2 because neither the A's or the B's wouldn't cancel, okay?
So 2 divided by 3. No, 3 divided by 1. The biggest has to be on the top.
Well, 3 is the biggest one.
Oh, you're right.
So we're going to do 3 divided by 1 because our A's are the same, okay? So our A's are the same. So we're going to do 3 divided by 1. And I'm going to convert this out. I don't like scientific notation right here. So we're going to say, now 3 is bigger than 1, isn't it? Because negative 2 is a smaller number than negative 1. So it would be 0.192 equals K 2.0. Now the 2.00.
I don't like scientific notation.
Is the scientific notation necessary on this part of it, though?
No.
No, because we know that they're both the negative 2, aren't they? Yeah. So I'm not going to put that in. I'm just going to put 2 in there. 2 to some power, and then 4. Now, it's important on this side, okay? It's important on this side because they're not all the same. But because they're all the same, there it doesn't really matter. And 4.00, so 4.00 to the y power. And we're going to divide this by what we say. We need something to cancel, so we're going to do experiment number 1. So this would be 0.0960 equals K.
Don't you have to put scientific notation?
With this, I took it out scientific notation. But negative 2 meant I moved it over 2 spots. I don't really prefer scientific notation. 2 to the x, and then 2 to the y. So this is 3 over 1. K's cancel, don't they? The x parts cancel, don't they? So to simplify this down with, we're left with 2 equals, because that divided by that's 2. 4 divided by 2 is 2 to the y. So what does y have to be? 1. So it's the same stuff that the next day's homework was.
Oh,
yeah.
Oh, I'm not lying.
Yeah, this is the same stuff. It's the same stuff as the next day's homework.
I need help on the first few questions.
So B is 1, B to the first power. Now, which ones you want to pick out for the x? There's nothing that's going to cancel, is there? So this one's going to be a little more math involved. Okay, you'd like to find something where the b's cancel, wouldn't you? But because you have nothing that the b's cancel, we have to use a different one. So it doesn't really matter what you choose. 2 and 3 is what you want to do. So 2 would be the bigger one. So I'd have 2.3. I'm going to work it up here. So we're going to go 2 over 3. 2.3 equals K, and then A, what did we do? 2, 4.
Wait, are you judging about what's bigger by the rate of D?
Yeah, the rate of D. That's what you want to determine. The biggest rate there. 4 to the x power. 4 to the x power. And then 6 to the y power, yes.
for the x power, and then 6 not to the y power, 6 to the what power? First power.
Why was the first part
Because we already found the d. We already found that y was equal to 1.
Okay.
And then over here we have, we did 3, you said, so 0.192 equals k. And then 2 to the x and 4 to the first. Okay. So so this is about to get really messy. So now I'm coming down here to the bottom, okay? So someone needs to do stop studying. 2.3 divided by 0.192 is equal to 12, okay? It's 11.97, basically equal to 12, equals, my k's canceled, didn't they? My 2 to the x power, and then 6 divided by 4 is 1.5. Everybody with me on that?
Why do you have to do the x power?
Because 4x divided by 2x. So
Wait, where's your 1.5?
6 divided by 4. So now we have 8 equals 2 to the x power. Because 12 divided by 1.5 is 8.
Is that a pound sign in between the 2x and?
Right here?
Yeah.
Yes, ma'am. So what's x equal?
X equals 4.
3.
3? How is it equal?
2 cubed. 2 cubed. 2 times 2 times 2 is 8.
Oh,
So up here, erase this. Instead of 3, we would write.
no, instead of
So x, we'd write 3. So x, we'd write 3. So that's the same thing as Thursday's homework too. Okay. Now I could ask you to solve for k. This question didn't ask. I didn't ask you to solve for k. If you want to solve for k, you just pick one of the experiments. So if we want to solve for k, I'd pick any experiment. So 9.6 times 10 to the negative 2 equals k. 2.0 times 10 to the negative 2 to the third power times 2.0 times 10 to the negative 2 to the first power.
If you have to solve for k, you have to do all this to find the x first.
Yes.
So you would
Please don't
do
do
like
that.
2.30 is the rate equals k, which is the x, and then put like 4.00 to the third power.
In that part, you'd have to worry about the times 10 to the negative 2.
Oh,
Okay.
Could you-
We didn't have to
that out?
here. We didn't have to here because they canceled out.
But you could just solve it, like,
Mhm.
get that out of time.
Yes, ma'am.
Can we use the first one?
No. Then resume. All right, so today we're talking about integrated rate laws, okay? So we have found our rate with regards to, we determined our rate laws experimentally, okay? So now we're going to talk about integrated rate laws. An integrated rate law relates to concentration and time. We never had time anywhere in that last one, did we? We just had rates. We just had rates and concentrations. So an integrated rate law means you take the integral of the rate law. It is not necessary for you to know how to determine the integral, okay? These equations are given to you. Remember, the first thing we did this year, we talked about half-life, okay? That's going back to this. Half-life is the amount of time it takes for half the reactions to be converted into products. Each integrated rate law and half-life equations are different for each order of the reaction, okay? Those are given to you again. You just have to be able to know which one is which. If a question asks or gives time, then you use the integrated rate law. That's the key thing there. If it gives you a rate, use the rate law equation, rate equals k to some power, stuff like that. So first order is what you've done. First order is what you've done. This is what we did at the beginning of the year. We talked about radioactivity. What? Yes, we did.
No, we didn't.
First quarter. Very first thing we did this year.
I don't remember this at all.
Very first quarter. Very first thing. We used ln of AT over that. So the rate law of a first order reaction, rate equals k to a power. If you go back and you do the integral of it, you find the integral of that thing, that is it, okay? ln of a t over ao equals negative kt. That's the same thing. If you divide ln, it's the same thing as subtracting. I prefer, what? Yeah, I prefer this equation, okay? And this is the one that's given to you on the AP exam, okay? This is the one, this one doesn't give it to you. This is the one here. Yes. Got
What's
you.
that little number by A in the second?
AT and AO. AO. That's the initial amount, okay? The initial amount. And K is our rate constant, okay? K is our rate constant, and T is the time. Your half-life is ln2, it equals ln2 over K. I prefer 0.693. If you put ln2 into your calculator, you get 0.693, okay? But here's the big thing to take out. This was some of your homework, okay? That bookwork, the 4 through 18, okay? It asks you what order something was, okay? What are the units for a first order reaction? I don't like this, okay? Because it's not necessarily always in seconds, okay? I like to say that the units of K are an inverse time, okay? So 1 divided by time. Because if you look at everyone get your periodic table out. Everyone get your periodic table out. And on your periodic table, look on the back side of it. The back side of it is it gives you the half-life. It tells you on the second from the top on the right-hand side, tells you the half-life of the longest lived radioactive isotope. So when you're talking about
What exactly is a half-life?
half-life, everything that is radioactive disappears. Okay? We know that carbon disappears. We know that in carbon-14 takes 5,730 years for half of it to go away.
Oh, okay. So just like if I die at 60, my 30 would be my half-life. Because I'm half.
Nah, not necessarily. It's for you to go away. Yes, and that's a way to look at it, okay? That's a way to look at it. And that's how they use half-life for carbon dating, okay? That's how they can go tell how old a fossil is, because they can see what percentage of it is still there.
So if it took 60 years for her body to decompose, her half-life would be 30. Because she would be going away.
If it took 60 years for half her body to go away, her half-life would be 60. Nothing ever completely goes away.
You know what I mean?
So matter can't be created.
Yeah. So nothing ever completely goes away. It's just transformed into something else. Typically, it's transformed into energy or something else. Okay.
What's the half-life?
So what happens to carbon when it goes?
1.1.
Converted to energy.
B11 years.
What'd you say? That means times 10 to the whatever year, to 6 years. Okay. So my point of this is it's not always seconds. Okay. It's usually whatever. Like I'm not going to talk about carbon's half-life in terms of seconds because it's 5,730 years, but it's inverse time. Okay. It's inverse time. A first order reaction. This is a big thing. They love to ask questions. You're going to graph ln over time. Okay. ln over time. The slope of the line is your K. So I will not today. Later on this week, you'll have a graph to solve this from. And if you want to find it, and you want to find the K, you just find the slope of the line. The y-intercept is the AO. So if you would back this up, so you would put a line of regression in here, and whatever your y-intercept, y equals mx, y equals mx plus b. Your m would be your K, would be your negative K, and your AO would be your B. Okay, and it's ln A versus time as a first order. I like to remember this because what equation? What's in this? ln. All right, first order reactions. Okay, thorium-231 decays by beta decay. Remember we talked about a beta particles and an electron. It is 0, -1 e to form protactinium. I think it's protactinium. No, I don't even know what PA is off the top of my head. I'm gonna work it out. What? Yeah. Thorium decays by beta decay to form Pa-231 with a half-life of 25.5 years. To find the rate constant for this process. Find the rate constant for this process. Protactinium? Yeah. Yeah. I was doing something on my end. I'm sorry. I'm going to copy and paste it also into the. I'm working on it. Let me do it this way. I know I'm working. Not much.
Yeah,
All right, so thorium 231 decays by beta decay to form protactinium. I made put in full screen to make it quick. With a half-life of 25.5. I found the rate constant. Remember, the rate constant is K. So I have my equation. I had two equations. We know beta decay is code word for it's a first order reaction. We're really talking about alpha or beta electron. Really, when we do this, they'll say alpha or beta. That's code word for first order reaction. So we had our two equations for first order reaction. We had Ln, give me a second, of AT over AO equals negative KT. And the other equation we had on there was T1/2 equals Ln2 over K. You go ahead and ask your question, Miss Ray. Yes, ma'am. They're both, yeah.
What's that
AT over AO.
So what
AT,
what does the order matter?
It's because each order has a different integrated rate law. Okay? Each order has a different integrated rate law.
Do we need both of these?
We're going to talk about, do we need both of these equations on this problem?
What is that?
What equation do you need, the left one or the right one?
Probably the right.
The right one.
I can't even tell what the right was.
T1/2 equals Ln2 over K. Because I'm giving half-life, aren't I? Giving half-life. So so T1/2 is your half-life. So we know that 25.5 equals Ln2.
Ln is Ln2 always 0.6?
Yes, ma'am. Yes, ma'am. 0.693. Ln2 is always 0.693. Yeah. So to solve this out, so K would be equal to Ln2 over 25.5. I'm solving for K. I'm asking for the rate constant, so I'm solving for K.
What's the answer?
So the answer is, you put in your handy dandy calculator, equals 0.0272. Now, I don't want to put in scientific notation. What's my units? Not seconds.
M/hour.
Inverse time.
M/hour.
No. There's no molarity in this one.
Negative hour.
Negative hours. So hours to the -1. Or you could say 1 over hour. Okay, it's the same thing. That hopefully bringing something back there. Hopefully that's bringing something back. Hours to the -1. 0.693. All right, here's my next equation. My next equation, the decomposition of ammonia into its elements is a first order reaction with a half-life of 200 seconds at room temperature. How long will it take for 1.0 molar of NH3 to decompose into 0.625 molar of NH3? Okay, so, got same two equations. We have our same two equations, Ln of AT.
Wait, are we choosing equations?
Yes, ma'am. Over AO
The same one.
equals negative KT, and T1/2 equals Ln2 over K. So what equation? What equation are you wanting to use?
Second.
Valen says the first one. Okay, so we'll go with Valen here. Okay, so Valen.
We also have half-life.
Valen tells us we use, so by AT, I will tell you, AT is always the smaller amount. So AT would be 0.625, okay? AT is always a smaller amount. AO is always the larger amount because naturally things decompose, they go away. Equals negative, we're looking for the K, aren't we? What's my time? Wrong.
That's the half-life, isn't it? The question asked
How long?
how long. So I don't know K or T, do I? But I have enough information to solve for K, don't I? So it told me the half-life is 200, isn't it? So we know that 200 equals ln2 over K.
So we need both.
Yes. Equals ln2 over K. So K would be equal to ln2
0.693
divided by 200. So what's that? Point. So K equals 0.00346. Three significant figures would be correct. And the units of that would be inverse time. Okay, so it would be seconds to the negative 1.
What is under the 200 rule?
This
No, the other 200.
here,
The first 200.
200,
What is under it?
that's just rearranging the equation. Those are two separate things.
Is that a K? Is that a-
Oh, yes, right here.
No.
Here?
Yes.
Yes, all I did was rearrange the equation.
Okay, wait. Why did Balin say we had the initial and the final? I see like 0.625.
It's how long did it take for 1.0?
Okay, so that. Okay.
So now I'm coming back over here. I'm erasing my K. And instead of K, I am writing 0.9. Keep in mind, still negative there. 0.0346 times T. This negative is very important because an ln is going to give you a negative number here, okay? So that negative is just going to make things positive when you're answering. You're going to have a negative time. So T would equal ln of 0.625 over 1 divided by negative 0.00346. So that's exactly how you put in the calculator. ln, parentheses, 0.625 divided by 1, close parentheses, divided by negative 0.00346.
But isn't 0.625 over 1 is 1.625?
It won't always be that way. You know, you won't always start with 1, but yes, ma'am. So I need how many significant figures?
I don't know. Well, 1, 2, 3, 5.
I need 3 significant figures. Because this had 3, that had 3,
136.
that had 3. Not the correct answer.
I didn't think that.
Not the correct answer.
Then why'd you write it down? You're missing the unit.
Missing units.
Inverse second.
No, seconds. Time is just the unit of time, okay?
So the rate is inverse?
Yeah, the rate constant. So what? 136 seconds. I will tell you on the AP exam, just as an FYI, even if you'd have done this wrong, this would have been a 1-point problem on the AP exam, okay, on their scoring method. You got 1 point, or you got a half point for the correct answer, half point for the correct units. So even if you'd have the correct units, you got a half a point.
Can you pass with getting all the work done and all?
Depends on whether you're doing multiple choice.
I didn't get the answer. I did not know that.
All right, give me a second. Let me see your calculator. All right, so that's our first order. I worked those out. No, they went black now, but we just worked those out. All right, second order. Remember, a second order is rate equals k to a squared. Okay, because you sum up the exponents to figure out the overall order. Its units are a little different. Its units are 1 per molar per second, or molar inverse second inverse. Okay. Here's our integrated rate law. Now notice these are different. Okay, there is no ln on this anywhere, is there? No. In a half-life, the initial concentration is important. Okay, it is important in the half-life. So those are our 2 equations. Once again, those are given to us. Couple notes I like to make is there is no ln. Okay, there's still no ln, and k is not negative in this equation. Okay, couple examples with that. Looking at the graph of it. Now notice the graph is 1 over a. Isn't that what we are here? 1 over a. In a first order, we were ln a. We are ln a. So, and my time is still the independent variable in the x-axis. Okay, the y-intercept is 1 over AO. So I want to pick these out. Part of your homework tomorrow is going to be picking out the correct one, and 1 over that, there's no ln, would just be a second order reaction. Example of second order reaction. Example order reaction. I'll give you a second to write this down, and then I will work it out, okay? Hydrogen iodide decomposes into elements such a way the graph that 1 over A versus T is a straight line with a slope of 2.4 times 10 negative 21 per molar per second. How long does it take for 2.25 solution to decompose to 1.12? So let's work this out. This is a second order reaction. So our two second order we have our two equations that work in tandem. Our two second order reactions are 1, you need a library. 1 over AT. I think these are harder to solve out personally. 1 over AO minus 1 over AO. This should be a little.
Why was the library?
I don't know. I'm just reporting what. 1 over AO. Then you erase that, make that right that a little bit nicer. 1 over AT minus 1 over AO equals KT. Yeah. Where's my $25 for getting you? I mean, $12 for getting you to work on time. And then my other equation, I'll get it in a little bit. I'm teaching right now. My other equation, T1/2 equals 1 over K.
It's an all 40.
It doesn't matter. AO times K. Okay. So those are my two equations.
1 over AO times K.
Yep. Those are my two equations. Those are also in your notes if you have any questions with my messy handwriting. All right. So our question is, we want to know how long does it take to decompose. Now, does it give me half-life? Does this problem give me half-life? It gives me the two concentrations and the slope, doesn't it? So in this problem, I do not need the half-life equation, okay? In this problem, I do not, where's my mouse? Do not need the half-life equation. So 1 over, what is my AT? Once again, AT is always the smaller amount. What is my AT? 1.12. 1.12 minus 1 over, the AO is 2.25, correct? 2.2. What? They won't be. They won't be. Equals, what is my K?
Would your K be the slope?
C, senorita. K would be the slope, so 2.40 times 10 to the negative 21 times T.
Oh,
Yep.
I was gonna ask.
Well, all right. So I need some math done for me. So I need this side simplified. 1 over 1.12 minus 1 over 2.25. That is not equal to 1/2. That's a very common mistake.
It was same.
James Evans. So I'm waiting on my math. You have a calculator. Let's go.
Poor Balin. He's not a calculator at all.
I did one of them.
Oh, you did.
What's this left side simplified down into? 0.448
Yeah.
equals 2.40 times 10 to the negative 21 times T.
Could you show me how to do fractions on those Texas instrument tests?
Put in, yes, if you have one?
Yeah.
Okay, let's see if I work this out, it will. Alrighty, and then T equals 1.87 times. What are my units? What are my units? What was the time unit in K?
Inverse time.
Well, it was in seconds, so this would be in seconds, okay?
So that's your homework. I'm sorry I didn't get the zero order. Google you a video if you need it. It's just plugging and chugging stuff in.